Lesson 1-5A, Piecewise Functions. What is a piecewise function? Piecewise function is a function that is written using two or more expressions. Each of these expressions is defined on an interval, and none of these intervals should have any elements of their domains in common. When we graph them, you're going to use a couple characteristics. A dot is going to be used if a point is included on that part of the function. A circle is used for a point that is not included in the graph. So if I go back to here, here's an example of a piecewise function. Here you have an open circle, and here you have a filled in circle or a dot. If you see the open circle, that means that point is not included. So you're going to see more than one graph on this coordinate plane. And here's your piecewise function here. So you have different restrictions based on what you're given. Let's take a look at an example. It says graph f of x equaling the opposite, equaling x minus 3 if x is less than or equal to 1, and 2x if x is greater than 1. So the first thing I'm going to do is I'm going to look at this first part, which would be x minus 3, where x is less than or equal to 1. So I'm going to, so since it can equal 1, x can equal 1, I go to 1 on the x-axis. And if I put a 1 in for x, I get 1 minus 3 is negative 2. So I would put a point at 1, negative 2, since it can equal it because it has the can equal to sign here. And then I got to choose points, x coordinates that are less than 1. So if I put a 0 in, that would give me negative 3. And if I put a negative 1 in there, that would give me a negative 4. And you can see that it just keeps going down further and further. And so that would be my line here. And then the other one, 2x if x is greater than 1. So if I use a point greater than 1, so let's say I use 1 here, 2 times 1 is 2. It can't be equal to 1, so I'm going to put an open circle right here. So when x is 1, it doesn't equal that function, but that's the starting point where I can draw my line. So now I just choose points greater than 1. So if I put a 2 in, 2 times 2 is 4. I have a point at 2, 4. And then if I put a 3 in there, that would be 3, 6. So now I can draw a line, and that would look like this, with an open circle there. Now we're going to analyze the key features here. So let's do the domain first. I can use any x value, and it will land on either the red line or the green line. So the domain would be all real. The range I can put it as this, y such that y is going to be greater than 2, or y is going to be less than or equal to a negative 2. Other key features, the intercepts, x-intercept, there is none. The y-intercept, we would have 0, negative 3. Other parts, let's see, we could do, when is it increasing? We would say that it's always increasing. But really, you're looking at the slope. They both have positive slopes, so that would mean that we would always be increasing on that one. Now, you don't have to do every single key feature, but the domain, range, the intercepts, those would be the main ones that you want to focus in on. You could do the increasing and decreasing as well. Next example. Here it says graph f of x equaling 2/3 x if x is less than or equal to 0, 3 if x is less, if x is less than, this one should be a 1 right here. So if x is greater than or equal to 1 and less than or equal to 3, and negative 2x plus 5 if x is greater than or equal to 4. Then we're going to analyze the key features that are listed here. So the first thing I want to do is just graph this one, and I'm going to graph each one with a different color. So this one I'm going to do with red. So 2/3 x if x is less than or equal to 0. So if I put a 0 in for x, I get 0. I'm going to put a point here because it can equal 0. Then 2/3 x. Now for this one, I could use my slope of 2/3 to do this, but remember it has to be x values less than or equal to 0. If I go down 2 to the right 3, 1, 2, 3, I would have a point here. I can go down 2 to the right, left 3, 1, 2, 3. Because if I put a negative 3 in for x, negative 3 times 2/3 is negative 2, and that's what I have as a point here. So now I can draw my line. It starts here and it goes downward in this direction. I'm going to use green for this one, 3 if x is between 1 and 3. So it can equal 1. I'm going to have a point here at 1, 3, and then at 3, 3. And then I have a line between here, and it just stops there because they're giving me a starting point and an ending point. And then the last one, we'll use purple color, negative 2x plus 5 if x is greater than or equal to 4. So if I start with 4, 4 times negative 2 is negative 8. Negative 8 plus 5 is 3. So if I go 4, 3, actually that would be negative 3, because negative 8 plus 5 is negative 3. So I go 4, negative 3, put a filled in circle here because it can equal that. And then if I choose 5, 5 times negative 2 is negative 10. Negative 10 plus 5 is negative 5. So that'll be a point here. Actually be down here. And then if I put a 6 in there, that would give me negative 12 plus 5 gives me 7. It'll give me a point right here. And then if I drew my line, this would go down this direction. So now we can say our domain, or here the domain would be all real numbers. But there are certain parts where it cannot be, because you can notice between 0 and 1 on the x-axis, there is no domain here, and there's no domain here. So we have to do our domain a little bit differently. So our domain is going to be x such that x has to be less than or equal to 0. X has to be greater than or equal to 1, but less than or equal to 3. Or x has to be greater than or equal to 4. The range, the highest it goes is at 3, but there's nothing between 0 and 3. So our range is going to be more specific as well. We're going to say y such that y has to be less than or equal to 0, or y has to equal 3. There's nothing in between. Everything below 0 works. The x-intercept would be 0, The y-intercept is also 0. And then for x such that x is less than or equal to 0, the function is increasing or decreasing from left to right. For the red one, the red dots, that one is increasing. For the green one is constant, stays the same. And the last one, the purple one, that one is decreasing because it's going down from left to right. Next, graph this one. First one, we're going to use yellow. For points less than -2, so if I go to -2, put -2 in for x, I would have 1/3, or actually it's -2 divided by 3 minus 2 gives us -2 and 2/3. So that would give us, we can put an open circle at -2 and 2/3. Roughly that would be -2 and 2/3. We'd say roughly here we'll have an open circle, and we have to choose numbers less than that. So if I choose -3, -3 times 1/3 gives us -1, minus 2 gives us -3. So -3, -3, point here. So if I put do 6, -6, so -6 times 1 divided by 3 minus 2 gives us -4. So we have -6 and -4. If 6 and -4 would be right here. So our line would look something similar to this. Then we'll use green for this next one. It's 3 when x is greater than or equal to -2, but less than or equal to 2. So I put a point at -2, 3, and 2, 3. Solid line in between. Then I will use black for this one. Greater than 2. So if I put a 2 in there, 7 minus 2 times 2 is 4. So 7 minus 4 is 3. So I have 2, 3. Since I already have a point at 2, 3, I will leave that point as is. And then I'm going to choose, I'll just put a black in there because I know it can be there. It can't equal for that one function, but because it can equal for the other one function, it's going to have a solid dot on it. If I choose 3 for x, 7 minus 2 times 3 is 7 minus 6, which is 1. So 3 and 1. And if I put a 4 in there, 7 minus 2 times 4 is 7 minus 8, -1. Point here. That means my line is going down like this. And there's my function. Now the domain here are all, there's a domains, x values I cannot use. I can use all of them. So for this one, our domain would be all real. The range, here the range would be less than or equal to 3. So y such that y is less than or equal to 3. That's everything below that. The x-intercept, where is it across the x-axis? Crosses the x-axis at, it looks like 3.5, so I'll put 3.5 here. Crosses the y-axis at 3. And then for x such that x is less than -2, the graph of the function, so this is referring to our yellow one. Yellow one, this one is increasing from left to right. The -2, 2, that one is constant. And the last one, the black one, that one is decreasing. Example 2 says football coach is ordering new jerseys for the new season. The manufacturer charges $88 for each jersey when 5 or fewer are ordered. $75 each for an order of 6 to 11 jerseys, and $65 each for an order of 12 to 29 jerseys, and $56 each when 30 or more jerseys are ordered. So we're going to create a piecewise function to describe the cost of the jerseys, and then we're going to evaluate the functions when they give us some specific jerseys that we are going to purchase. So the first part, we need to write a piecewise function. So we're going to make this as f of x. F of x equals, and then we're going to have our brace here. And it says the manufacturer charges $88 for each jersey. So x is going to refer to the number of jerseys. So if I have 88x, it's 88x if when you have 5 or fewer jerseys ordered. So we'll put down if the least amount of jerseys you can order is 0. So it'd be greater than or equal to 0, but less than or equal to 5. Because you can order 5, and the maximum it costs you would be $88. Next part says $75 per jersey. So 75x if, and here for an order of 6 to 11 jerseys. So that would be we could do 5. Let's just do, so that would be greater than or equal to 6, but less than or equal to 11. If you wanted to go from x is greater than 5, you can do that. Let's just use 6 here. And then we have 65 per jersey if 65 jerseys if, or $65 per jersey if you have an order of 12 to 29. So when it's greater than or equal to 12, but less than or equal to 29. And then we have a cost of $56 per jersey if you're purchasing 30 or more jerseys. So when x is greater than or equal to 30. That would be our piecewise function. Now we're going to evaluate the function. What would it cost to purchase 11 jerseys? So if I go back to my piecewise, for 11 jerseys, I would use $75 per jersey. So going back to here, this would be 75 times 11, and 75 times 11 would give us $825 is what the total cost would be. What would the cost of 25 jerseys? So if I go back to here, 25 would be in $65 range. So I would do 65 times 25. So 65 times 25 would give us $1,625. And if we were to evaluate 29 jerseys, so let's just say what would it cost for 29? So f of 29. I would go back to here, 29. That would also be costing 65. So this would be 65 times 29. 65 times 29 would give us a total of $1,885. And our last question. for his graduation party. Santino's parents have hired a catering company to provide the food. The company charges a setup fee of $150. They also charge $6 per person for the first 50 people and $4.50 per person for each additional person. Write a piecewise function that models the amount of catering the catering company will charge if P people attend. In part B, determine the cost of food for 50 people and for 85 people. So we are going to do f of P equaling, and then we need to do a piecewise function. So it says they charge a setup fee of $150, so you have $150 no matter what. And then it's $6 per person for the first 50. So plus $6 per person, 6p. And this is if this would be from the first 50 people, so it'd be 0. That's be more than 0, but less than or equal to 50. And then the next one is going to be more than 50. So I'm going to put the if p is greater than 50. So to find out if there for 50 people, that's a total of $450. Plus, it's $4.50 per person. But remember, this is per person more than 50. So if you have 51 people attending, I would put 51 minus 50, which is 1. That's the $4.50 plus the 450 was for the first 50 people plus the startup fee. So this would be our function that our piecewise function would have. Then to determine the cost of food for 50 people, cost for 50 people would be $450. So f of 50 would be 150 plus 60 times 50, which is 300 plus 150, which will give us $450. Now, if there were 85 people, that means we use a second function, which would be 450 plus 4.5 times 85 minus 50. So 85 minus 50 is 35. So we have 35 times 4.5, and then add the 450 to that. That will give us a total cost of $607.50. So that is our lesson on piecewise functions.